So, when it comes to monitoring distributed systems, I've found that using distributed tracing really helps you get a handle on what's going wrong. Especially with all those microservices talking to each other.
Yeah, but setting up the tracers can be a pain sometimes.
Absolutely, and it takes some getting used to. But once you have Jaeger or Zipkin set up, it's like having X-ray vision into your system. And the best part? It's non-intrusive for the most part.
Still, there are times when adding the tracing code feels like it clutters the application logic.
True, but think about how much easier debugging becomes. Plus, you can use things like OpenTelemetry to abstract away a lot of that clutter. Oh, and don't forget about sampling strategies to keep performance in check.
Sampling can be tricky though, getting it right so you don't miss critical traces.
Definitely tricky, but crucial. You need to balance between capturing enough data and keeping your overhead low. And let me tell you, nothing beats finding out that a single API call was causing everything to slow down because of a database query issue.
That's true. It can save hours of digging through logs.
Exactly. Another thing is correlating logs with traces. If you can tie them together effectively, imagine being able to jump from a log entry directly to its trace context. It's like solving a mystery puzzle where every piece fits perfectly.
Sounds almost too good to be true.
Well, it does take effort up front, but once you've got your pipeline streamlined. Speaking of which, have you looked into health checks and liveness probes in your microservices lately?
Not recently. Why do you ask?
Just curious. They're essential for making sure your services are up and running properly. I mean, it's one thing to know a service is alive, but another to ensure it can actually perform its duties.
Right? So you're saying just knowing it's alive isn't enough?
Exactly. Liveness probes tell you if the container is still running, but readiness probes go further by checking if the service is ready to handle requests. It's like the difference between seeing if someone is breathing and ensuring they can work.
Makes sense. How do you typically set these up?
Usually with Kubernetes, you define them in your deployment YAML files. For example, a readiness probe might hit an endpoint that returns a status code indicating whether the service is ready to serve traffic.
Seems straightforward enough.
It is once you get the hang of it. And don't forget about initial delays and back-off strategies to avoid overwhelming your service with too many health checks at startup.
Initial delays? That sounds like a good idea.
Absolutely, especially in large-scale systems where everything starts up simultaneously. You want to make sure you give each service time to initialize without piling on extra load right away. Actually, speaking of ensuring services are up and running, have you thought about the performance metrics for your distributed databases?
Not really. Why bring that up now?
Well, monitoring performance metrics is crucial for understanding how well your distributed database is handling load and query. Things like read-write latencies, throughput, and error rates can give you a lot of insight.
That sounds useful. What tools do you recommend for tracking these metrics?
There are several good ones out there. Prometheus combined with Grafana is quite popular. It allows you to collect metrics from various sources and visualize them effectively.
I've heard of those but haven't set them up yet.
They're worth the setup time. Another thing to consider is setting up alerts based on certain thresholds. For instance, if your write latency goes above a certain value, you should get an alert so you can take action before it impacts users.
Alerts definitely sound helpful. How granular should we be with our metric?
As granular as necessary for your specific use case. Sometimes high-level metrics are sufficient, but other times you might need detailed insights into individual nodes or even specific queries. It depends on how complex your system is and what kind of issues you're trying to catch early.
Got it. So it's more about tailoring it to our needs.
Exactly. And don't forget to correlate these metrics with other parts of your system like application performance or network conditions. It's all interconnected, and understanding those relationships can help prevent downtime and improve overall efficiency. On that note, have you given much thought to logging strategies in your distributed environment?
Not as much as I should. What do you think is key?
Logging is crucial for diagnosing issues, especially in a distributed system. Centralized logging with tools like Elk Stack or Splunk can make a huge difference. It allows you to aggregate logs from multiple services into one place.
Agreed. Centralized logging would be a big help.
Absolutely. And make sure you're logging at the appropriate levels, debugging information during development, but only critical errors and warnings in production to keep performance up.
That makes sense. Any tips on what to log specifically?
Definitely log request and response details, timestamps, user IDs if applicable, and any unique identifiers for transactions. This helps trace the flow of operations across different services and pinpoint where things might be going wrong.
Useful pointers. How about log rotation and retention policies?
Good question. Log rotation is important to manage disk space, and retention policies depend on compliance requirements and how long you need historical data. Typically, keeping logs for 30 days is a common practice, but it varies based on need.
Makes sense. Anything else to watch out for?
Always ensure your logs are searchable and structured properly with JSON or another format that makes parsing easy. Also, consider using log shippers like FluentED or Logstash to move logs efficiently from your services to your central logging solution.